Very good morning, students. My dear students, myself B K Singh, your science teacher from Oriental Public School, Kishanganj. Dear students, hope all of you are doing good at home. And today, in this video, we are going to discuss the lenses and the image formed by lens. Dear students, today we will discuss the lenses. First of all, we will discuss that spherical lenses are of two types, and these are concave lens and convex lens. Students, if we see, we can categorize convex lenses into three categories, and these are biconvex or double convex lens. Second, this is a biconvex lens or double convex lens, and second one is students, that is plano-convex. This one is plano-convex lens. That means one side it is having convex and another side it is plane. That's why it is known as plano-convex lens. And third, student, that is concavo-convex lens. Concavo, that means one side it is concave and another side it is convex. That's why this is called concavo-convex lens. And after this, student, we will discuss the concave lenses. They are also of three types, and these are, you can see these one here. These are, first one is biconcave lens. Biconcave lens. That means here both the surface is concave. Second one is plano-concave lens. Plano, that means one side is concave, another is plane. And third, student, that is convexo-concave lens. That means one side it is convex, one surface is convex, another surface is concave. So that's why it is known as convexo-concave lens. So students, in this way we have seen these both concave and convex, both are of three types. Now students, we will discuss the few key terms used in lens description. And number one, this one is center of curvature. First is center of curvature. So students, the center of curvature of lens is the center of the sphere of which it is a part. And after that, student, radius of curvature. Radius of curvature. So this one is the radius of sphere of which the lens is a part, is known as radius of curvature. After that, student, we will discuss principal axis. Principal axis, student, principal axis, that is the imaginary line joining the center of curvature of two spherical surfaces is known as principal axis. And next one is, student, optical center. What is optical center? Again, the imaginary point lying inside the lens on the principal axis, passing through which a ray of light emerges undeviated, is called optical center. After that, student, we will discuss focal point. So what is focal point? The point on principal axis at which the parallel rays of light converges after refracting through the convex lens is known as focal point. And next one is focal length. Student, the distance between the optical center and the focal point is known as focal length. And after this, student, we will discuss that how images are formed by lenses. So for this one, student, we should understand that there are few rays which are very important, or the most convenient rays used to draw a ray diagram. These are: number one, a ray parallel to the principal axis. No, the ray parallel to the principal axis. The ray which is parallel to the principal axis, after passing through the lens, it passes through the focus. That is, we can say, if this is principal axis and the ray which is parallel to the principal axis, after passing through the lens, it passes through the focus. This is focus here. So this one is very important ray, we should know. Second ray which we should know is a ray passing through the optical center. Second ray, the ray passing through the optical center. Students, the ray which passes through the optical center, that do not get deviated. It passes undeviated. Suppose this is the point of optical center, or this is the optical center, that one we used to represent by O. So if any ray which will pass through the optical center, it will pass through the lens without deviation. That is another ray which we should know. Third, a ray passing through the focus. A ray passing through the focus. So the ray which passes through the focus, that after refraction, after passing through the lens, it becomes parallel to the principal axis. That one we can see here also. Suppose this is a lens and this is the principal axis and this is the focus. Suppose this is the focus. This is the focus. So a ray which passes through the focus, after passing through the lens, it will become parallel to the principal axis. This is the third ray. So in this way, it is not only in case of convex lens, but also in case of concave lens also is the same case. That means in concave lens, like suppose this is a concave lens, the first ray which we had said the ray parallel to the principal axis, after passing through the lens, it will go in this direction, but it will appear that it is coming from the focus. No. And second ray which we have discussed, the ray passing through the optical center, will pass through the lens without deviation. Suppose this is the lens and this is the optical center. So if any ray will pass through it, so it will pass through it without any deviation. And students, after knowing these rays, we will discuss what will happen when the object, which type of image will form when the object is at different position in front of a convex lens. So we will discuss first the image formed by convex lens first. So for that one, we will discuss when the object is at infinity in front of a convex lens. Suppose this is a convex lens and the object is at infinity, like sun is at infinity. So suppose from there, if the rays will come, so all the rays from the sun will come to us, will be parallel to each other. And for that one, for the formation of image, student always will have to take two rays. One ray, two rays, those two rays which will intersect after refraction or appear to intersect after refraction. So those two rays will have to take. So in this case, if we will take one ray which is passing through the optical center, another ray which is passing through the focus. Suppose this is a principal axis and here it is a focus. So another ray which is passing through the focus. So we know the ray which is passing through the focus after refraction No. Okay, it become 1 minute. After passing through the oh, after passing through the uh, after passing through the student, we can see it here also. After passing through the focus, the ray will become parallel to the principal axis, and both the rays, after passing through the lens, it intersect at F. So in this case, student, we can say their property will be, first property is that the image form, the image will form at focus F2. No, here it is forming. You can see here. So in this whole place it is forming. So it will form at the focus. And second thing, real and inverted. Student, you know, real means the image which we can obtain on a screen is known as real, and inverted if the head of the object is in upward direction and the head of the image is in downward direction. So that image is said as inverted. So, and we have also discussed when we were discussing the image formed by the mirror. So in that case, we had said that real and inverted goes side by side. That means both at the same side. If it is real, definitely it will be inverted. Third property is, friend, it is highly diminished. Diminished means smaller. Diminished means smaller. So it is highly diminished. Like sun is very big object, but that object when it forms its image, so it is very smaller, and which we can obtain on a screen at a point also. So you can imagine the so big object whose image is forming at a point, to how diminished or how smaller it is. So it is said as very highly diminished it is. Next, student, now we will discuss the when the object is beyond the center of curvature. So in this case, student, see, if the here also we will have to take two rays, one which is passing through the focus, and after passing through the lens it will become parallel to the principal axis. Another ray which is parallel to the principal axis, after passing through the lens it passes through the focus of the lens. So in this case, what do we see? Both the rays are intersecting at this point. So here the formation of image is taking place. So in this case, the property of the image will be, the image will form between F2 and 2F2. That means it is said 2F2 stands for the center of curvature. So we can say focus and center also. And here also, student, the image will be real and inverted. And third, it will be smaller in size. And next position, student, now we are going to discuss when an object is at the center of curvature, that is at 2F or C also we can say. So in this case, student, again we will have to take two rays, one ray which is passing through the focus, after passing through the lens it will become parallel to the principal axis, and another ray, student, which is parallel to the principal axis, after passing through the lens it will become, or it will pass through the focus. And when it will pass through the focus, both the rays we can see, student, it is intersecting at a point. So at this point only the image will form. In this case, student, the properties of image will be, first property, the image will form at 2F, that one we can say C also. Second is the real and inverted. It is real and inverted, you know both, and it is a smaller size as the object. Whatever the size of the object is, from that size, the size of the same size as the object. That means it is same when the object is at center of curvature. At that time, the size of the object and image will remain same. And last, student, when the next one is when the object is between F and 2F. So in that case, what F and 2F, in that case, student, the image will be beyond 2F. It will also be real and inverted, and it will be magnified. That means bigger than the object. After this, student, the remaining things we will study in later classes, in later videos. Thank you for watching this video. Have a nice day.